right, hi everyone. Welcome to week 38. We're going to use your payload development kits, and we're going to learn how to use them to breadboard and set up our circuits and our payloads to test with this software and this flight computer. We're going to start by doing that with an LED circuit. So first of all, we'll turn on the LED and just get it to turn on and make sure that it's getting the power. And then from there, we're going to send some code from the STM32 Cube IDE. We already set it up for you. You just need to download the file and import it. We'll go over that. And then you're going to send the code to the microcontroller board here, and we're going to get that LED to blink, hopefully. Okay, so what you're going to need for that is your kit, your payload development kit, and all the stuff from last week, including the debugging cable, the power cable, the USB A to C cable, your payload hat board with the socket pin or the socket headers already on, a couple of jumper leads, probably just a red and a black, and we're going to also grab your breadboards and an LED. Sorry, this is getting crowded. An LED and a resistor. Now, we're not going to go over calculating resistor values today, but if you go back to the previous weeks from last year when we talked about calculating a resistor value, you'd look at the data sheet for the LED, see how much current it could take, the voltage, and given that the voltage we're supplying is going to be 3.3 volts, calculate the resistor value to make sure we don't exceed the allowable current. But today we're just going to set it up. Okay, so I'm just going to move this up a little bit to give us some more space. So the first thing you're going to want to do before we set up, we will test our payload dev board. So I've turned this one on at the wall. The payload board itself is still switched off. So see, switch is still in the off position, but we are going to test changing our multimeter from off to DC voltage test. Go to ground, you can see that there. Ground pin and VBAT, and check that we're getting the correct voltage. So that's the 9.27, so that's fine. So then we will go ahead and switch our payload on so we can see it. And then you're going to have ground here and VBAT. Still 9.3, that's good. And we'll check our 3V3, which is the one we're going to use. 3.3, excellent. Okay, so switch that back off. Put our multimeter aside. Tidy that up. Move our debugger cable for now over here. So we're going to start with putting our LED into our breadboard, remembering that there's an easy way to tell a fresh LED from the positive and negative terminals. The positive side is the longer leg or the anode, and the shorter leg is the cathode or the negative side. So you can also see that the cathode side has a slightly flattened side. So if your LED has been cut down, you can check that. So we're going to pop that in to our breadboard, just anywhere. Now, I'm not going to use the power rails today because I only have a couple of cables handy. I'm going to go straight into the terminals, but remember you can use your power rails if you just have more cables. So clip your hat board in there, and then we're going to take our ground, because we're always wanting to connect ground first, and we're going to go into the ground pin here, which is the middle on the sockets. If you're having trouble reading the labels on the silk screen here because of the socket headers, you can always go to your one that doesn't have that on there, because you should have that in your kit from last week, and or you can go to your paper diagrams that you submitted for CDR. So ground, so I'm just going to remind myself which is ground. So I've got it in here. So we're going to put that in the same node, if you can see that hopefully there. All right, and then we're going to take our resistor, all right, this is 220 in this case is the one I've gotten, and you can check that by reading the bands, remember, the color coding, or you can use your multimeter to do that. And then I'm actually going to pick this up from the power rail. I'm going to go into the positive and go into the power rail, right, because we don't want too much current flowing through there. And then connect from there, because on the power rails, remember the connections run this way, so I'm going to go take that. I'll take it actually over here. Oop, I'm not very coordinated today. There we are. And we're going to go into 3v3. So this is, for a lot of you, how you'll start. This is very basic power to your payload components, depending on your circuit. Okay, so we're gonna go ahead and switch that on, and hopefully our LED is gonna turn on. Hey, excellent. So that's on, that's great. So the next thing we wanna do is we want to switch it off again, take our debugging cable, right, this one here. If it's not already connected, you just have to connect that there. And have a look for the little notch. So see how there's a little notch there next to my thumb? And then match that up there. And gently press that in. All right, and then I'm gonna take the end of your USB cable, so USB-C, and you're gonna plug it in there. And then the other end goes into your computer that's got STM32 Cube IDE installed, and you're logged into your MyST account. Okay, so the first thing we want to do is actually switch our payload board back on so the light turns back on, and then open STM32 Cube IDE software. We're going to import the file that Will Blackie has already configured into the software, but first we're going to check that you're logged in with your MyST account. So go up to to Help, click on that, go down to STM32 Cube Updates and Connection to MyST and click on that. If it says clear MyST account information for this computer, you're already logged in. But if you're not logged in, it will prompt you to log in with your username and password that you created last term. So please do that if you need to. Right, so you will have downloaded a zip file that was provided with this week's material. Wherever that's downloaded, we're now going to import it to create a new STM32 project from an existing STM32 Cube MX configuration file or .ioc file. So go ahead and click on that. And it's gonna take a minute. And then browse to wherever it is that you've downloaded it and unzipped it on your computer. In my case, it was in the downloads, which is my dumping ground. Double click on BinarX payload there. So open that up and navigate through till you find the .ioc. So that's the one you want to either double click or click open. Open. Right, and then you can leave everything else as it is. You might want to just change payload to be your team name or your payload name or just a meaningful name. And then we'll click make note of where that's saved. It will be different on your computer, and then click finish. So it might also come up with a window saying it was created using an older version. I usually always click on migrate, it doesn't hurt it, and then it will stop hassling you. So migrate, and now we wait. All right, and you'll see this pop up here, this chip. Now remember from previous weeks, hopefully that this is the chip that's on your board, a visual representation of it that's on your BinarX micro boards, and then all the pins that come out from that microchip onto the board. And they've all been pre-labeled by Will, which is fantastic, and those user labels, so the text that's on the white part of the screen here outside of the little pin graphics, so if you zoom in and have a little look, those are the labels that are referenced in the code. So don't change the names of any of those. If you do, so the user label is what they're called. Those user labels, or whatever is outside in the white field here, that's what, if you need to control that pin, that's what the name and the label you use in your code, and we're going to go through that in a minute. So for all the sensors, all the pins on your hat boards, it's the sensor one starting with sensor. So sensor GPIO 1, sensor GPIO 2, sensor GPIO 3, and if you scroll around, you can sort of click and drag, and it will let you look around at the other pins. So click and drag. You can see sensor ADC1. We're looking for sensor GPIO 2 and 3. Where are they? So there's GPIO 3. And we've got the ADC pins. So if you look on your hat boards, you've got ADC 1, 2, and 3, and 4. If you're using any of your, actually not those ones, any of the SPI ones, it's actually not those. If it doesn't say sensor in the front, it's not the one you're going to want to connect to. So just be on the lookout for that, but we won't worry about that this week. You just need to be aware. We're just going to use sensor _GPIO GPIO_1. So go back up to your Project Explorer and follow the mouse up in the top left and click on Core to drop it down and SRC, and then we want to open our main.c. So double click on that and it'll open, and you can see at the top there's tabs, but this is all the code that's already pre-configured to run the payload and initialize all the pins. You're just going to need to put your code in. So if you go down to about line 116, this is where we're going to put the code to blink the LED today. It's a while loop. So make sure you don't put the code in between those two comments, because when you build it, it will actually clear that. We're going to go up there and we will put in a carriage return, hit enter, and type HAL, HAL underscore GPIO underscore right pin, bracket, sensor underscore GPIO underscore 1. So that's the user label, remember, of the pin that we saw on our IOC file. If you go back over there, you can double check. That's the one that you want, sensor underscore GPIO underscore 1. And then back to main C, we'll keep typing, so just put your cursor back in there. And then underscore GPIO, so that's just what type of pin it is in the setup. You want to make sure that is right. And underscore port, comma, space, sensor, underscore GPIO, underscore 1, underscore pin, comma, GPIO, underscore pin, underscore reset. So that's, we're basically sending a reset command to that pin, and then we'll put a comment, so // that sets our LED to off, as we want to start it in an off state. Then the next line, HAL underscore delay, and open bracket 1000, close bracket, semicolon, all important semicolons, and then comment, that's an insert delay of 1000. If you remember the units, milliseconds. And don't need to put a semicolon in your comments, but we'll put one here anyway. And then we're gonna basically write our code to turn the LED on. So it's very similar to the previous, the first line of code, HAL underscore GPIO underscore right pin, and please pay attention to the capitalization that we're using here as well. Underscore sensor underscore GPIO underscore 1 underscore GPIO underscore port. Oh, I'm not good at typing today. Port, comma, sensor underscore GPIO underscore 1 underscore pin, comma, GPIO underscore pin underscore set. And semicolon after the end close brackets. So then comment, that will set our LED to on. And then I'm just going to copy and paste to save some time, because we're going to have another delay. So that's going to basically turn it on, wait a second, turn it off, wait a second, and keep looping. So now we want to send that to our microcontroller's chip. So to do that, we want to first make sure we haven't done any typos, have a little look at it. It's looking all right, but what we'll do before we send it is we'll build it. So if you go up to the top left and you see a little hammer, and click on build, that's the build. So down in the console, it'll go through all the things that it needs to do. Don't worry about this, but what you want at the end is to not have any errors. So you see there at the bottom, it's saying 0 errors, 0 warnings. Great, so now we're ready to send it to our debugger. So we can hit that little play, green play looking icon. And this might pop up. You can just check it. If you're having problems with the debugger, it's asking for a serial number. Just make sure you haven't specified a serial number for your ST link in there. So that's all fine. I think that's all right. So we'll just say apply and okay. And it's telling us now that there's a newer firmware available for our debugger, which can sometimes come up. So if you get this message, if it doesn't come up, it's fine. It means it's up to date, but then just click on yes. And then you'll get this open in update mode. Don't worry about changing type, just leave that unchecked and upgrade. Wait for the magic to happen. Upgrade successful, great. So you can close that and then we'll hit play again. Oh, looks like it built it anyway. There we go. Okay, now it's going. You'll see your little LED on your debugger flashing green and red when that's being sent through to your microcontroller, and it's all good and down. Okay, so now that we have set up our code in STM32 Cube IDE the way we want to, we can send that through to our microcontroller board. So once you've done that, yeah, it'll send through. And nothing's happened yet because we've still got this this connected to 3v3. It's not connected to the GPIO1 yet, so let's switch it off. Now that we've programmed, you've sent your code to the microcontroller, turn it back off because we don't like to move wires when the payload is powered on. So we're gonna just take that then, and then as per our code that we've sent to our microcontroller, put that into GPIO1 and switch it back on. Ah, success! We have a flashing LED. And you can play around with that code to your heart's content and get it to blink other things if you want. But that is effectively it for this week, and this is how you're going to start building your own circuit payloads that you designed last term, and start plugging those into these before we solder it onto here, which is the goal for the end of this term. All right, any questions as always, please email us at binarx@curtin.edu.au, and I'll see you all next week.